Let's follow our method once again for dealing with this particular problem. We will again find first the eigenvalues, and remember we only need to pick one. And so this will be the determinant of a minus ri is equal to 0. It's our characteristic polynomial. So this is now the determinant of not a, but of 2 minus r minus 5 over 2, 9/5, negative 1 minus r. Multiplying that out, I'm going to leave it to you to work out the details of the algebra, but you end up with r squared, used to lambda from last time, r squared minus lambda minus r plus 5 over 2 is equal to 0. You can solve this using the quadratic formula. When you do so, you will find that r is equal to 1 plus or minus 3i all over 2. And we can automatically see that if we were to pick one of these, let's pick r1, which is 1 plus 3i, that since our lambda is positive, this will be unstable and spiraling away from the origin. So for my one eigenvalue, I will find the eigenvector. Which is going to be 2 minus 1 plus 3i minus 5 over 2, 9/5 minus 1 minus 1 plus 3i, all times c1, c2, and we know the pattern, right? We know that we're going to cancel one of the rows, so just pick one of the rows that you want to work with, and it will be fine. So the row that I would like to work with, after I've simplified this, hold on a second. This should be this should be 1/2, and this should be 3/2. My apologies. So after we simplify this, we end up with 3 over 2 minus 3 over 2i minus 5 over 2, 9/5, and minus 3 over 2 minus 3i over 2 times c1, c2 is equal to 0, 0. Just pick one of the rows because that's how this works. Let's do the first one. We'll get 3 over 2 minus 3 over 2i times c1 minus 5 over 2 c2 is equal to 0. And so I know this looks a little complex, but you would end up with 5 over 2 c2 is equal to 3 over 2 minus 3 over 2i c1. The 2's can go away. The 2, and you can multiply through by 2/5 if you wanted, and so that you would get c2 is equal to 3/5 minus 3/5 I c1. What this means is that you could pick c2 to be or c1 to be anything. I could pick c1 in this case to be 5. So take c1 to be 5, because that seems to take care of the fraction, and you get 3 minus 3i for my c2. And so this would be the eigenvector that we're going to use. Step 3 is we need to put this together so that we can separate everything and decipher the two vectors that are going to create my solution. So our x1 is going to be the eigenvector, which is 5 and 3 minus 3i, times e to the t over 2, cosine of 3 over 2t, plus I, the sine of 3 over 2t. Remembering which is a scalar and which is vector, we're going to take the e to the t over 2 and move it to the side, and I'll end up with 5 cosine of 3 over 2t plus 5i, the sine of 3 over 2t. And underneath, we have to FOIL this out, and we get 3 cosine of 3 over 2t plus 3 sine of 3 over 2t minus 3i cosine of 3 over 2t plus 3i, the sine of 3 over 2t. If you need to, pause the video to make sure that you can get the same answer. The way I'm multiplying it, I know that the i's are going to when I have I times I, it's equal to -1. So I'm doing first 3 times the cosine, -3i times this. And then I do 3 times the sine and -3i times this in order to get the imaginary parts. So this is going to end up with the following. This will end up with e to the t over 2. And on the top, we're going to get 5 cosine of 3 over 2t. And on the bottom, we're going to get 3 cosine of 3 over 2t plus 3 sine of 3 over 2t. And we'll get e to the t over 2 times I, 5, the sine of 3 over 2t, and minus 3, the cosine of 3 over 2t, plus 3, the sine of 3 over 2t. And we drop the I, so that we end up with our u and our v, which are linearly independent of each other. And we can use this to create our solution, our general solution, which is c1 e to the t over 2 times 5 cosine of 3 over 2t, 3 cosine of 3 over 2t plus 3 sine of 3 over 2t plus c2 e to the t over 2, 5 sine 3 over 2t, -3 cosine of 3 over 2t plus 3 sine of 3 over 2t. And so that would be our general solution to this particular problem. We have also been asked to do the phase portrait. So we kind of need to know whether it's going to move in the counterclockwise or the clockwise direction. So taking the point, or taking 2, -5 over 2, 9/5, -1, times the point 1, 0, to find out which direction this is going to circulate. We already know that it's spiraling away from the origin. So 1, 0, when I multiply it through, will give me the point 2, 9, 5. So from 1, we will go up 9 over 5, which is going to be 1 point, almost 2, will be almost 2, and over 2. So we are heading in the counterclockwise direction, and we're spiraling outward. Secondly, we notice that our top is weighted more than our bottom, and so we're going to be ovular again, oval pattern, where we're stretched out by 5 across and 3 up. And so our circles are going to do something like this. Also make sure to put your arrows to indicate which direction that they are. Oh, I did them in the wrong direction, didn't I? They're heading inwards in this particular case. So let's try to redo this. We have to head outwards, away from the origins of this. Sorry, not even that. Yes, that. Nope.